Hello everyone. I've set it out on my little board here. Um, these are my little mirrors. Maybe I can show you these a bit better now. Just made some little stands. Where are I getting camera? Jesus, back to front. Anyways, that's all they are. I've just glued them all together, and but you can see that they're cheap and nasty. But yeah, one thing that this can be improved on is by buying some manufactured prisms, really. But anyways, these are things that I've made. I've got 3 of these, so these are my little beacons. So basically they're passive beacons. There's no electronics or anything attached to them. You just stick them in 3 places around your little robot in the middle, and all I do is I just sort of measure between centres. I've made these all about 500, so it doesn't matter really. Whatever they are, you just measure them and measure across. Oh, they're a bit wide of that. Hang on, I'll just bring that in a bit. Yeah, there we go, about 500. What's that one? Is it still 500? Does it want to come out a bit? Maybe shove that one over there a bit. How's that? Yeah, that looks about 500 now. Gain there. I'm making it 500 because that's what I put in my little thing. Well, I'll show you anyway. So I'll just leave the ruler there because we can use that to do checks and measurements. So I just kicked the camera. Right, yeah. So there it is spinning. So the lasers shines on the mirrors and it gets reflected back. And then there's down here is me little let's point to it. Yep, down there is my ESP8266, and on I've got there is a web server, as I've said before. So let's have a look and log on to that web server. Give me a moment. Right, I've just moved the camera over a bit. You can only see 2 mirrors, but you can get the picture. You don't really need to see it actually. So we just need to look on what my web server is on the thing. In fact, actually, I'll just make this full size. There we go. And basically, if we go to the debug tab, we can see that again. As if it turns green, it gets a good signal. But the distances between the 3 beacons, there's 3 distances. You just need to type in here what them distances are and save, and then everything is calculated from them. So there's no setting out of the beacons. You just take these 2 at the bottom as the x-axis, sort of measure between them, and then stick this beacon up here somewhere, and you just measure whatever distance is between them 2. So you've got A and B, B to C, and C to A. So basically, that's all you do. So once you've done that, then you can just go to the robot view, so you can see it's there, and the accuracy I've got at the moment. The accuracy can be increased by putting a better laser on with a thinner point. It's got quite a wide lens. It's a bit like those laser pointers you get. It's a couple of 2 or 3 millimeters wide. So if we got a laser that was minute, but that's expense again. So this is a cheaply made thing. You get more accuracy, and also my 3 mirrors. If we bought manufactured prisms, then the accuracy would be a lot more accurate. But you can see that it sort of bounces around uh, a value. You can see it move here, and the compass. Alright, so yeah, I've added this compass. I quite like the compass. I wanted to make something that spinned, so this is all new to me in web coding, so I thought I'd give it a go. So if I just sort of go like that, so you can actually see the robot, and what I'll do is I'll rotate it left and right, and then you can take a look at the compass I've got down here. It's only up. What I've done is when it's orange, that means it's got a bad signal. When it's yellow, that means we're getting a good signal, and it will adjust things when it's yellow. So I'll turn it, and then we've got to wait for a little bit of yellow. So if I can do it without kicking the camera over. So yeah, I'll just turn it to the right. There we go. We can see that the compass follows it. If I turn it the other way, just wait for it to update with some decent values. There we go. You can see that the compass. I'm quite pleased with that myself. It was something that I wanted to have a go at doing. So yeah, so let's just get it pointing back north again. So we'll just point it north. There we go. Pretty close. And then what we'll do is we'll check the measurements. What I've got is I've got a ruler here. What I'll do is I'll just put the ruler up against it like that. And what are we in the X? We're about 287 in the X direction. What I'll do is, well, I'll move it as, let me see if I can move it so it's just in shot still. So I'll just take it along the length of this ruler. We're still in shot there? Oh yeah, plenty there, right, so let's just go a bit further. Yeah, so we're in shot there. What we are on it? Right, 159.60. It's about 160 there, isn't it? Oh, 140. Yeah, it's bouncing around about 150, isn't it? So what I'll do is I'll just set my ruler to 100 there, and I'll move it 100 mil this way. Where are we? There's a 200 there. So I've moved about 100 millimeters there in the X direction. So what we got there? Yeah, 242. Well, you can see on the screen, yeah, that it should have been around 250, I think, something like that. Let's just try that. Let's see if I can get it onto 250. I might not have moved things right. Let's just get that across a bit further. So it's reading about 250. 249. Yeah, it bounces around a bit. This is all to do with the thickness of the laser. It's bouncing around 250, isn't it? Ish. Yeah, I believe that. Shut my eyes. Right, let me set the ruler at 250, and I will move it down to 200. Oh, hang about, I'll just knock the... where did I have that? Yeah, there we are. Hang about. There's 200, so it should be reading... Oh, shall I say bouncing around 200? No, it isn't, is it? Oh, is it? Oh, yes, it is, yes. I'm looking at Y, it's X. Yeah, it's bouncing around 200, so let's go down to 150. I'll move it to 150. Oops. back up again. Well, yeah, I think it's about 150 there. Let's have a look. Oh yeah, well 147, 50, yeah, 152, 151. Yes, bouncing around that again. So let's do it in the other direction. I'll put my other ruler. What we on? Y 170. Let's see if I can bring it back to say 200 that way. And let's just bring this. What's it saying? It is in the Y. I'll move this one. Right, what we're saying Y163. So if I move this to 163, 163, that should then be about 200. Let's have a look. Oh, 230. Oh, well, that's a bit. Oh, 218, 230. Let's call it 220. Let me put the ruler back to. Oh, I've got it on 220. What am I on about? Yeah, I've got it on 220. Can't read my own writing. The thing. This is 200. There. Let's try that again. See what that does. Yep. 204, 199. Let's take it back to 150. Well, actually, let me just move this. Let's see if that will go under there. Get it further in shot, I think that's all. What is X? 190. Oh, it's supposed to be. It was about 200, wasn't it? So I'll just move it to. Let's see how far. Let's just move it 50 mil. See if I can get this right. There's 25. Oh, yeah, I want it on 25. Yeah, that's 250-ish. Yeah, 250-ish on X. And then what I'll do, that's on the 200 mark. Let's bring it all back 100 mil. So let's get rid of that again. Yeah. Slide this down to the 100. There we go. Dragging all the wires with it. Close. How are close on the thing? Yeah, 97, 95. Let's move it all the way up to the end of the rule. What's it saying there? 91, 95. Let me just readjust the. Yeah, put it at 90. So let's see if this should go up to 250. Should be about 250 there. Are we? 254, 268, 257. Yeah, anyways, you can see it move. So let me just do some random numbers moving around. So basically, we get what we're doing. This goes on top of a robot. As it moves around, it spins. The laser's reflected off the mirrors, and we get its position. Like I say, if we rotate it as well, if I rotate it round, then our compass will move with it as well. And I go the other way. I think I'm pulling wires out. Yep, there we go. And let's just face it north again. If I can, something like that. Well, it's close. See what that update's like. Oh, there we go. I'm slightly off. Straighten it up. There, just straighten it up a touch. Yeah, and we can get it on north. There we go, that looks straight. Yeah, well, yeah, it's been a nice project. I hope someone enjoyed it and understood what I'm trying to achieve. Oh yes, I forgot to mention. Yeah, I took a shortcut with the code. Well, most of the code. Well, the positioning code. Basically, I've used there's some credit here to Lingib on the Instructables. Those Instructables where he's done the maths here for working out the position. You might not recognise it, or you'll see some of it in there, but to change a few things for the way I'm doing it, I have, like I said, in the what did I do with that? Yeah, in this, I am actually putting these numbers in here. So I put these into wherever you put the beacons, and so where are we? Yeah, so that's these values, them three values: A to B, B to C, and C to A. So then I just get the angles, the two angles that I work out from. Let me just move that slightly. Yeah. I just from this page I get the angles here, and I use those angles in here, these two, and that's it. Oh, and yes, mine is flipped. In the original code, this beacon B was down here, and the beacon A and C were up at the top. I've flipped them over and mirrored things to make it work the way I want it, because I wanted it like this, where this is origin and this sets my sets my x-axis, and this is my origin, basically always from this first beacon. That way, in practice, I can visually see that is the area. I do have some things to do. Well, I don't know if I've sort of got to where I want to be with this project, but the only thing I'm better off showing you on here. Right, my three beacons are just mirrors, so I can't identify which beacon is which beacon, and so my compass only works as long as I don't turn the robot round past one of these beacons. Otherwise I have to rotate the whole thing, the formula, through probably about 60 degrees to get the compass right. So as long as I don't do like a complete 180 turn in rotation, I'm okay. But other than that, it's I've enjoyed doing the web page, and so that you don't need any other any other software than what is actually on the ESP8266, because all the code is actually uploaded to that, and you just view it on any device you like that can view a web page. You can view this on your phone, tablet, even Linux using a web browser. Anything that has a web browser, you can actually see that. The scaling might not be quite right. I'm not very good at making it scale right. If I reduce this down, let me just see if I can make this smaller. I've tried to scale it, but you can see what happens if we do that. You can move the slider up and down, but can you see these numbers? What I should do is actually make that fixed and the numbers scale, but my compass don't come out too bad when you scale it across, sort of like that sort of thing. So yeah, I'm still learning. Okay, guys, I hope you enjoyed that, and I've tried to make the screen look like a sort of, the radar effect of the old radars. Anyways, if you've watched it this far, thanks for watching, guys, and I hope you enjoyed it.